Greetings, Earthlings. Today we're going to take a look at the variants of the 6809 microprocessor. As you may recall, if you watched the previous video, I bought what claimed to be a 68B09E from Jameco, and it appears to be a regular 6809. And so I've actually gone and purchased some true 6809Es. They're 68B09Es. Those came from Twisty Wrist Arcade, and they are actual pulls, whereas the Jameco ones are apparently remarked chips, and who knows what their history is. But there are two basic types of 6809 processor. There's also a 6309, which I know nothing about, so I'm not going to talk about that. But there's the original 6809, which we can see here, and it uses an external crystal. So pins 38 and 39 are the crystal inputs, and then it generates these Q and E clock signals. Okay? The 6809E, and by the way, those A, B, and C in the middle of the part number, 68A09, 68B09, that kind of stuff, and there may even be a C, that's a speed variant, so we're not going to worry about that for this discussion. The E version, the E stands for external clock, and what they did was they said, okay, we're going to move that clock generator off the chip. You're going to generate the Q and E clock signals, and that leaves us a few extra pins that we can use to make building multi-processor systems easier. That's functionality I don't need. So I would be happy, for my purposes, with either a 6809 or a 6809E. And as we go through this here today, I think what I'm going to do is show that we can actually design the circuit to take either processor with just a simple, say, jumper change to specify which processor it's actually using. And that way I'll be happy with either one. So we're looking at here, this is the one, the mismarked one, and there is the crystal. That is a color burst crystal, whatever that is, 3.579 megahertz or something, connected to those two inputs. Over here, I have a 4 megahertz oscillator, and then a JK flip-flop. This is 74 HCT73. If we go back and look at this, that's this part of the circuit. But we'll look initially at the driving it with the crystal here. And what I can do is I have the oscilloscope here of my logic analyzer hooked up to those Q and E outputs, which are the quadrature clock signals. I'm going to turn the power on. Oh, hi, I'm the Troy McClure of power supplies. Yes, we know, you tell us every single time. And you can see here that that's the clock signal it's generating from the crystal. However, if we read the data sheet for the 6809, what it says is that we can actually use an external clock on this. There are two pins, extal and E-extal. If we ground extal, then we can put a TTL level input. If we the pin E-extal may be used as a TTL level input for external timing by grounding extal. Okay? So I'm going to power off. I have this sort of already set up here. I am going to pull that out. I am going to hook that there. That's just the output of this 4 megahertz oscillator. And I'm going to ground that pin, and we'll start it up again. And we can see that indeed it's generating those same type of signals again. The timing should be a little different because this is 4 megahertz as to whatever the other one was, 3.579. Okay. So that's cool. But now my question is, so again, this chip appears to be a 6809 or 68B09. For my purposes, I don't need the B speed. The regular 6809 runs at 1 megahertz, which means a 4 megahertz input clock because it divides by 4. The B09 runs at 2 megahertz. For my purposes, I only need 1 megahertz, so I don't really care if it's a B part or not. But as long as we've got the logic analyzer out, let's hook it up and see if this actually acts like a 6809 processor. Power off. And I do happen to have it pre-wired here. Oh, what a mess. Uh-oh, and I lost one. Okay, I'll fix that. Oops, I lost 2. Okay. Hazardous. Oh, did I lose another one there? Okay. This one went there. Ay, ay, ay. Where did this one go? I see a bent pin, so that must be it. Okay. On the clip. Okay. Now what I've done here, let's switch it. Okay. Let's switch it to waveform. What? No, we don't want analog. Oh, where am I? Yeah. Oh, which one do I want? Here, look. Let's do it this way. I was in analog only. There we go. Okay. So I'll put it in. Here we go. There we go. Okay. Now I go here. Okay, and I already have it set up. Okay. Let's see. What I've done is I've wired the data lines. Okay, D0 through D7 to hardwire to them to hex 12. 12, 1, 2. Hex 1, 2. Hex 1, 2 is a no-op instruction. When the processor starts, when it's reset, it will go to location FFFE and read the 16-bit value at FFFE, FFFF, okay? So since it's always reading 1, 2, it's going to read 1, 2, 1, 2 as the 16-bit value. That is the starting address, okay? So then it will say, okay, set the program counter to 1, 2, 1, 2, and proceed from there. It will read the value from location 1, 2, 1, 2. That will be a 1, 2, which is a no-op, and so it'll say, great, I'm going to 1, 2, 1, 3. I'll just increment the program counter, and so on. And so what we should see now, let's see, the trace is set up, so I'm triggering on that FFFF, because if I hold the reset button down, it's always generating an FFFE. And so when I tell it to run, see, now I'm holding that reset button down. If I tried to trigger on FFFE, it would be done with the trace right now, and I'd have all FFFEs. But when I let it up, you see, there it is, FFFF, FFFF. This isn't right. I'm expecting to see 1212. Oh, there it goes. Okay, I don't know. Oh, it was already running was the thing. Maybe I didn't press the button properly. The reset. Okay. So before the FFFF, we had FFFE continuing back to infinity. So when I came out of reset, it read FFFE, FFFF, and there's 2 cycles per, as you can see. Don't worry about that. Then it went to 1212, 1213, 1214, 1215. Okay. So this is looking like an actual 6809 to me. I really believe that it's just a mismarked chip and not a total counterfeit. That's nice. But I have some true 6809Es as well. So I'm going to try one of those, and this will require reconfiguring the circuit slightly. Of course, it's taped shut. Okay, so power off. And we will attempt to remove the clip from the chip. Oh my goodness. How many things will we break this time? Ah, good. Came off nice and easy. Okay, now we're not going to hook that up, because what was the crystal input is now, let's see, where's my cheat sheets here? What was XTAL is TSC, which is tri-state control, which we don't need to worry about. What was EXTAL is LIC. LIC, last instruction cycle. TSC, XTAL, which you ground on the 6809. Let me bring this up. Okay. Here's the thing. On the 6809, XTAL, we ground to say we're using an external clock. On the 6809E, what was XTAL, pin 39, is TSC. TSC is an input. 3-state control will cause MOS, address, data, and read-write buffers to assume a high impedance state. And TSC is active high. So we need to ground TSC if we're using an E because we're a single processor system. Well, that's great. So in either case, with either chip, it will be grounded. That's good. Okay, let's see if I can get this chip out. So at this point, I have, excuse me, I have nothing connected to the clock input. Okay. This chip is a 68B09E with a date code of 1980, looks like 88. Okay. And something I saw online said you will not find a genuine E version of the chip with a date code after 94, I think. It's like 94 or 96. This other one is a 1993 date code. So I am going to plug that in where that was, hoping that I don't blow this guy up. All right. Hoping I don't bend any pins. Let's have a look. Okay, that looks good. Now, I need to take the Q and E signals. They now become inputs on this chip. So I have, okay, let's go over here. See, now I can do this. Okay. Oh, except it's, okay. It's gonna cause problems, but you see on the lower trace, the upper trace goes up in the middle of the top there, okay? Make sure we get the phase correct. Okay. I'm going going to power on, and I'm going to tell it to run, and it's not going to run because there's no trigger. There's no digital trigger, which is bizarro. So I press stop, and there it is. So it actually did capture, and you can see that in the top, that's going up. So this is the correct phase, except I don't remember which one came from which one. So we'll try to figure this out. And that's going to go there. All right. Let's put the clip back on. Gadzooks. Oh, I see the problem. And I managed to do it without knocking off any of the little clippies. Okay. Can you see that? There's wires in the way. Okay. Let's switch it back to state mode. Oh, no. You know what? Oh, that was bad. I didn't turn the power supply off. Okay. Well, I didn't kill anything. I am rather fortunate. All right, let's try this. Run. All right, what happened there? Oh, it's in continuous mode. Wait. Stop. Single. Okay. Back to list. Okay, roll it up. Roll it up. Okay, roll it down. Okay. Oh boy. Don't try this at home, kids. Always be sure to turn the power supply off before making changes to the circuit. Otherwise, you may end up with blown up circuits, chips, which is why I get extras, you see, because I've probably blown up one or two in my day. Okay, there we go. Yay! And as we see, this is with the true E chip now, right? That's running off of this clock generator over here. And okay, so FFFE, back to infinity there. 1212, 1213, 1213, 1214, 1214, 1215, 1215. Now this is interesting. I see only one instance of 1212 here. I would have thought that I'd see that twice, just as I see all the others twice. So I don't know what's up with that. But yeah, it's consistent. So I don't know. I'm gonna go back and read the manual. But anyway, okay. So going back to our circuit here. I don't know how well you can see that. But what we can do now is, let's see. There's 39, which I show as TSC. Here's 38, which is not connected. I can put a jumper from here and connect that over to 38, okay? And then it's simply a matter of inserting this chip or not. Because I don't, because yeah, if I've got an E chip, then I don't include the jumper, but include the chip. If I've got a non-E, then if I've got an E, plug the chip in, but no, yeah, that's what I said. If it's an E, no jumper, plug the chip in. If it's not E, leave the chip out and put the jumper in, okay? And it will work with either, because again, I'm not using those multiprocessor features of the E chip.